Gamma functions. The gamma functions appear in the solution of various physical problems such as normalization of Coulomb's wave function, computation of probability. In statistical physics, the gamma function is generally denoted by the Greek letter gamma. Various forms of gamma function. If gamma function is generally defined in the three types: infinite series form, the term of infinite series, the gamma function is defined as gamma z 1.2.3.4 up to n over z into z plus 1, z plus 2, z plus 3 up to z plus n into n to the power z, where z is not equal to 0 or minus 1 or minus 2 or minus n. The domain of gamma function can be real or imaginary. Now let us prove one by one. The first property, gamma of z plus 1 is equal to z into gamma of z. Now we know that gamma z is this definition. Let us replace z with z plus 1. So gamma z plus 1 can be written as 1, 2, 3 up to n raised to the power z plus 1 over z plus 1, z plus 2 up to z plus n plus 1. Multiply and divide by the above equation by z. So what do you get? This is n, this term n into z over z plus n plus 1. I have multiplied this term by z. So we can get nz divided by this term z plus n plus 1. Since I have taken n raised to the power z plus 1 as n to the power z and n. Now this is gamma z, this other term is nz over z plus n plus 1. Now let us take limit n tending to infinity. Now this term can be written like this. This will be 0, this will be 0, only 1 will be left. So what is proved? Z, gamma of z plus 1 is equal to z into gamma of z. Now note that gamma is one of the few functions in mathematics that does not satisfy the ordinary differentiation. Also, gamma of 1, if z is equal to 1, we can put n to the power 1 divided by the same term. Now this can be written as n over n plus 1. Since all the terms will cancel out up to n, only this term will be left. Limit n tending to infinity, if I do 1 over 1 plus 1 over n, this tends to 0, only 1 is left. Also gamma z plus 1, we have proved equal to z into gamma of z. Put z is equal to 1. So it is gamma of 2 is equal to 1, gamma 1, which is equal to 1 only. So it is 1 factorial. Similarly, 3 gamma is 2 factorial. Gamma 4 is equal to 3 factorial. Gamma 5 is 4 factorial. And we can write gamma n equal to n minus 1 factorial. Hence, we can say that gamma can be interpreted as factorial of a continuous function at integer argument. Now, definite integral form. The gamma function in definite integral form can be defined as gamma z 0 to infinity e to the power minus z t to the power z minus 1 dt, or gamma n is 0 to infinity e to the power minus z to the power minus n minus 1 into dz. Integrating the above function by parts. So we can get minus, this is t to the power z minus 1 e to the power minus t 0 to infinity, plus the other function, since that we'll write the derivative of t to the power that. On successive integration, we have gamma z, which is equal to z minus 1 into z minus 2, z minus 3, and so on. z1 is z minus 1, z minus 2 up to so on. Last is 1. So we can get z minus 1 factorial. Let us replace z by z plus 1. So gamma z plus 1 is z into z minus 1, z minus 2, and so on. We can write z into z minus 1 factorial, or it is simply z factorial. Another form of gamma function in the definite integral form can be written as 0 to z infinity e to the power minus z, z to the power n minus 1 dz. Now let us substitute z by lambda y. So dz is equal to lambda dy, or 0 to infinity e to the power minus lambda y lambda into lambda y raised by n minus 1 lambda dy. So it is 0 to infinity. This whole term is equal to that gamma n divided by lambda to the power n. Substituting e to the power minus z equal to y, so we will get this relation is 0 to infinity like that. Z is equal to log of 1 over y. Dz will be minus dy by y. So what will be gamma n? This will be 1 to 0. This whole term is log n minus 1 dy. That will be 0 to 1. Since we have changed this negative sign, log 1 over y n to the power minus 1 into dy, or 0 to y log of 1 over y n minus 1 dy, which is again equal to gamma n. Now if you substitute z to the power n equal to y, so we'll get z is equal to y raised by 1 over n. Dz 1 over n, y raised to the power, this term after differentiating, putting the value here in gamma, 0 to infinity, e to the power minus y 1 over n, and this whole term as it is. So if you take n to this left side, n gamma n is 0 to infinity e to the power minus y raised to the power 1 over n dy. Substituting now, n is equal to half. So gamma half is under root pi. 1 over 2 gamma half is 0 to power infinity e to the power minus y square dy. It is under root of pi by 2. So gamma half is under root pi. Now let us do one numerical. Prove that 0 to 1 x to the power m log of x to the power n dx is equal to minus 1 power m over m plus 1 power n plus 1 into gamma n plus 1. Let I is equal to this integral. So put log of x is equal to minus t. So x is equal to e to the power minus t. Differentiate both sides. Dx is equal to minus e to the power minus t dt. So 0 to infinity e to the power minus mt minus t raised to power n and minus e to the power minus t dt. This is what the integral of that. So if I write equal to this minus 1 to the power n e to the power, combine the powers of e t to the power n dt, substituting m plus 1 into t equal to u. So what is t equal to? U over m plus 1, or dt is equal to du over m plus 1. So my 0 to infinity, putting the values in that integral, we get this whole term like this. All constants, take them out of the integration, like minus 1 power n, m plus 1 power n plus 1. Rest inside. 0 to infinity is e to the power minus u to the power n du. Or 0 to infinity, u to the power n plus 1 minus 1 du. Why we are writing like this? Because we know that this whole integral is equal to gamma of n plus 1. So the answer is minus 1 to the power n, m plus 1 power n plus 1 into gamma n plus 1. Now let us do one more question. Prove that 0 to 1 x log of x to the power n dx is 4 factorial over 5 raised to the power 5. Now let us put m is equal to 4 is equal to n. 0 to 1 x to the power m, this whole term that we have just now derived the answer like this. 0 to 1, x to the power 4 log x to the power 4 dx, that will be equal to 1 over 5 factorial 5 to the power 5 gamma of 4 plus 1, or it is gamma 5 to the power 5. This is 4 factorial divided by 5 to the power 5. Now prove that 0 to infinity e to the power minus x to the power 4 dx is equal to gamma 5 by 4. Now let us take I is equal to this. Put t is equal to x to the power 4. dt is equal to 4x cube dx, which is 4t to the power 3 by 4 dx. So what is dx? dt by this. So putting the integral 0 to infinity e to the power minus t raised to power minus 3 by 4 dt over 4. 1 over 4 gamma 1 by 4. So this is gamma 5 by 4. In a Maxwell distribution, the fraction of the particles with speed v is between v and v plus dv, which is given by this expression, where n is the number of particles, then the average of expectation value of velocity is given by this expression 0 to infinity v to the power n dn by n. Then show that this value can be written as v average equal to this gamma n plus 3 by 2 gamma 3 by 2, or can be written like this. Now how do we prove it? Given that the average value is v to the power n into this, or 0 to infinity, put the value 4 pi m over 2 pi kt. Now from here this term is coming, this is what given dn by n is given by that. Putting the value of dn by n here. Substituting mv square by 2 kt equal to u square, or v square is equal to that, or v is equal to 1 root of this. So differentiating both sides, dv is equal to under root 2 kt over m into du. Putting the value back into this integral, this, what do you get? 0 to infinity, the whole term as it is, rest of the terms in that expression like this. Constant terms, let us take them out. These are all the constant terms we are taking out. Inside integral we are left with u raised to power n plus 2 e to the power minus u square du. So the whole constant term as it is, 0 to infinity e to the power minus u square u to the power n plus 2 du. Put under root x is equal to u, scaling both sides, x is equal to u square. Differentiate, dx is equal to 2u du. So what is du? It is equal to dx upon 2u, or which is under root of x. So putting value back, constant term as it is, 0 to infinity, this term is left like that. Rearranging the terms, cancelling the terms, we get constant, only this term, e to the power that, x to the power n plus 1 by 2 dx like this. Constant as it is, what is this term? Now from that definition, it is gamma of n plus 3 by 2. Under root pi is always equal to that gamma 1 by 2, or this is equal to 2, this whole term like this. This is gamma n plus 3 by 2, and this will be gamma half. Or rearranging the terms, we get the answer like this. This is how we prove that answer. So that is what the application of gamma function.